Hello. In this pre-lecture video, we are going to be talking about the beginning of Chapter 3. So this is Lecture 6, Pre-lecture Part 2. I just wanted to make the video a little bit shorter when I realized that, or I wanted to put it in two parts when I realized that the first part of Pre-lecture 1 was getting very long. So let's go ahead, or Pre-lecture 6, Part 1 was kind of long. So I stopped so you guys would have smaller amounts. Okay, so in Chapter 3, we start talking about the idea of stoichiometry. So this is when we are going to be looking at measuring our elements. Amounts of reactants and products, basically. So we're going to be using the conservation of mass and energy, specifically the conservation of mass part of this. We are dealing with a chemical reaction now. So we're looking at chemical reactions. And with chemical reactions, we generally conserve mass. And we're going to use that idea that we conserve mass in chemical reactions and apply it to our chemical reactions to figure out how much product we should produce with a given reaction. So we're going to look at our law of conservation of mass and energy. Which is that our mass can either be created or destroyed in a chemical reaction, but we will have a conservation of both mass and energy. And this is by a French scientist, Antoine Lavoisier. Okay, so with this law of conservation of mass and energy, we start to look at the idea of balancing equations. So if we have an equation, we're going to have the same number of elements of each type on both sides. So if we took a reaction like this, for instance, CH4 plus O2 goes to CO2 plus H2O. Here we have a reaction. We have carbon, oxygen, and hydrogen. We have it on the left side of our reaction, and we have it on the right side of our reaction. And the number of carbons, the number of oxygens, the number of hydrogens should be the same on both sides. So if we look, we have one carbon on the left side, one carbon on the right side, good times. Two oxygens on the left side, one on the right, less good. Four hydrogens, two hydrogens. Again, not very good. So with our balancing equations, we want to take this reaction and make sure that both sides have the same number of carbons, same number of oxygens, same number of hydrogens. And we do this by adding in what's called a stoichiometric coefficient. So something before each of our chemicals in order to balance them out. So let me just make some notes in here real quick. These right here, these subscripts are going to be there to indicate how many atoms are in that chemical formula. These cannot change. Okay? So you never ever change those subscripts in order to balance a chemical reaction. These you can change. You can put a number in front of these. These are our stoichiometric coefficients. And those tell us how many of each of our chemicals. So the subscript tells us the amount of atoms in a particular compound. So for instance, with CH4, that's carbon, 1 carbon, 4 hydrogens. If we change that to CH2, these two things are no longer equivalent, right? So we can't change the number of hydrogens within a chemical formula. That changes the substance. So keep that in mind. Subscripts do not change. But our stoichiometric coefficients, how many of each substance we have, can. These pluses here, we've got pluses on the left side and pluses on the right side. That means that these on this side, these react together. So we would say that methane reacts with oxygen, CH4 reacts with O2. And this side is our reactants. This means to produce. And then on this side, these are our products. So on the left side, we've got our reactants. So we would say that CH4 reacts with O2 to produce CO2 and water, or H2O. Now, when we're balancing, we need to figure out what to put on as our subscripts in order to change this. So as a general rule, you're going to do this in kind of a order. So when you are balancing your equation, you're going to balance out metals first, then non-metals with the exception of oxygen, hydrogen, then oxygen, then hydrogen. So balancing order. First are metals, then non-metals. Okay. So within our nonmetals, we're going to do polyatomics. If you see a polyatomic on the same polyatomic on both sides of a reaction, just balance the polyatomic as a whole. Then all other nonmetals except oxygen and hydrogen, and then oxygen and then hydrogen. So you'll do metals, nonmetals, starting with your polyatomics, then everything else, then oxygen, the hydrogen. So let's try it up here, and I'm actually going to rewrite this down here. So we've got CH4 plus O2 reacts to produce CO2 plus H2O. So carbon, oxygen, hydrogen, carbon, oxygen, hydrogen, 1, 2, 4, 1, 3, 2. And I think I actually put 1 up there, didn't I? It's supposed to be 3. Okay, our carbon's good, so move on to oxygen. There are 3 on the right side, 2 on the left side. If you see something with 2 on the left side or 2 on one side, an even number on one side, odd number on the other side, try and make your odd side even. So I'm going to put 2 here, and then I could put a 2 here. So that goes to 4, that goes to 4. And then that goes to 4. And then we're good. Boop. Yay, very easy. They get much more complicated, right? And we will do some examples But let's try one more with a little bit more to it. So H2SO4 plus NaNO3 react to produce Na2SO4 plus HNO3. So we have sodium, it's our metal. Then we have SO4, NO3, and H. So that'd be the order in which you would balance these. Okay, first thing we want to do, balance out our metal. So I'll put a 2 on this side. Then balance out our polyatomics. Sulfate's good. Nitrate. And then we've balanced out our hydrogen. Good times. Okay, so some notes about our chemical reactions. It tells us what reactants are there, what substances are reacted, and what substances are produced. But it also tells us information about the state in which they react. So we have reaction conditions. Okay, so I want to show you the different reaction conditions that you may see in a reaction. So, one, you're going to see chemical states. You're going to see solid, which will be written as an S, liquid, an L, gas, G, and aqueous, AQ, which is that substance is dissolved in water. Okay, so if our reactant is a solid, it'll have a S, a liquid, an L, a gas, a G, dissolved in water, AQ. There's also going to be things above the arrow, and that gives you information about how the reaction, or what type of things are there on the reaction. So you'll see an arrow, and above the arrow you may see a delta. That means that you're going to have heat applied. Okay. You could also see that's H nu. That means light is applied. Okay. So seeing something above the arrow means there's different conditions, reaction conditions that are applied. Okay. Next I want to talk about chemical reaction types. There are several reaction types that you will need to be able to look at and know just by looking at the reaction. So we have combination reactions. So here we have two things reacting together to produce one product. We have decomposition reactions. It's kind of the opposite of a combination. We have one reactant breaking down to produce two products. We have combustion reactions. Combustion reactions, we have some sort of hydrocarbon reacting with oxygen to produce carbon dioxide and water. Okay, these are going to be reactions that have flame and produce heat, burning things. We have redox or oxidation reduction reactions. And these are going to involve the transfer of an electron from one substance to another. So here we're changing charges. And usually you'll see these involve some sort of metal salt. So you have a metal reacting with a salt to produce a new salt and a new metal. Okay, that's going to be the most common that we'll see with that. Next is our precipitation reactions. And here you're going to have a precipitate form. So you have, here we're actually looking at states. So you have two things that are in the aqueous state. So you have two metals, salts. So you have two ionic substances dissolved in water. And when they are combined together, they produce a solid. Okay. Last reaction type we want to look at is acid-base. Neutralization reactions. Not the only type of acid-base reactions, but we're going to have an acid. So remember from last chapter what an acid looks like? It has some anion with a bunch of hydrogens. It's going to react with a base. A base has that hydroxide, something like sodium hydroxide. And in this process, you're going to produce an ionic species. This is called a salt. A salt is the product of an acid-base neutralization reaction. And then water. So those are our different types. So we have combination, decomposition, combustion, redox, precipitation, and acid-base neutralization reactions. You will need to give products for a lot of these reactions, and you'll need to recognize when you have a specific type of reaction. Next, I want to talk about the idea of a formula weight versus a molecular weight. So we have looked at our periodic table and looking at things in terms of AMU. So if we look, carbon's 12.011 AMU. But if we take carbon and we put it into a substance, we can combine all of those atomic weights to get what's called a formula weight or molecular weight. So our formula weight is the sum of the atomic weights of everything within the chemical formula. Okay, so this is going to work for ionic compounds and covalent compounds and molecules. All things can have a formula weight. A molecular weight is a formula weight specifically for covalent substances. And you'll see formula weight abbreviated as FW, molecular weight as MW. Those are very common. So we'll look at actually figuring out formula weights. We'll do a couple of examples. They're pretty easy. And the last thing I want to talk about is the idea of elemental composition. So here, it's a percent composition of an element within a compound. So by mass. our percent composition is given by the following equation. So you'll take the number of atoms of a specific element, times it by the atomic weight of the element, divided by the formula weight of the compound. Okay. That is everything. We will look at how to solve for these in this chapter. And yeah, so see you guys tomorrow.